Hi Year 12s, welcome back to online learning. Whoa. Okay, so I'm going to do some videos for you now because I do them for my Year 8s and 10s, so why not you guys too? So, here's our first exercise, problems involving simultaneous equations. This is where we're up to. So I'm going to give you a chance to copy down the notes. So do that, pause the video because you won't have time to copy them all down. Pause the video and I'll talk to you about it in a minute. Alrighty, so I've already worked out last lesson, before we got back in lockdown, about how to solve simultaneous equations. So there's different methods. You can do it graphically, you look at the graph, but it's not very accurate. You can use algebra, so you can use the substitution method or the elimination method. They take a bit of time, or use CAS. You're allowed to use CAS for every single question in all your tests and SACs, so use CAS. It's the easiest way. Alright, so I've said here all the stuff from last lesson. To solve worded problems, you need to write the words into two equations. You need to define the variables, like we've done in the past. Use CAS to solve for them, for the two pronumerals. So remember the point of intersection of a graph, that's actually solving those two equations. And make sure you answer your questions in words, and remember, use units as well, or else you'll lose a mark for units. Alright, here's a very common question that we get in SACs. This is straight from the textbook, so if you need extra help, go back to that. Two methods of paying a gas bill. Method A, you've got a fixed charge of $25 a quarter, but then the unit usage of the gas is 50 cents, so it's higher. Method B, you've got a more expensive quarterly charge, but then the cost per unit is less, it's half as much. So there's two different methods of paying. And it says there, determine the number of units that must be used before method B becomes cheaper than method A. Because as you can see, method B at the start, it costs more. Whereas method A is cheaper if you're only going to use a little bit of gas. So you've got to use a little bit of common sense there. So what it's actually asking us is, where's that point of intersection? Where is it, after how many units is the cost going to be the same for both of them? And that's where you determine. If you use less than the point of intersection, you'd use one method, more you'd use the other one. Alright, so the first step is write the equations. So I come back here, and this method A, so I'm going to call that cost 1. The total cost of method 1 is 25 per quarter and 50 cents per unit. So 50 cents is 0.5. I'm going to call X the number of units we use. Okay, and it's $25 fixed rate. So that's a fixed cost, and this is our variable cost. Remember, in straight line graphs, that's our y-intercept, and that's our gradient. Alright, the next one has a fixed charge of 50, but it's 25 cents per unit. So the cost of method 2 is 25 cents per unit, and it's $50 per quarter. Excellent. So we've got our two methods there. Now, if you want to put this into CAS, you just put the two equations in and solve. I showed you how to do that last lesson. But you can also, if you want to do it algebraically, so this is going to take extra time, but where the point of intersection is where the costs are the same. So you can say, this is cost 1, and that one is the cost 2, so you let those two equal each other. So you go 0.5x plus 25 is equal to 0.25x plus 50. If you want to solve it algebraically, you can do that. Minus 0.25 from each side, and minus 25 there, because 25. Divide by 0.25, and you get x equals 100. So if you did use that using CAS, you'll get the same answer. So x is 100 units. So remember, x is the number of units of gas that we're using. So we sketch the graph now. So it doesn't ask for that in the question. I'm just going to do it just to help your understanding. So the cost of 1 has a y-intercept of 25. So let's just make that there, $25. But it's got a gradient of 0.5, so 50 cents. So it's going to have a higher gradient. And this one, we'll say is $50, has a y-intercept, but its gradient is only 25 cents per unit of gas, so it's a flatter curve. So therefore, this is our point of intersection, POI, our point of intersection is there. And remember, when you've got two graphs, what must you do? You must label them both. So this one is the cost of 1, and this one here is cost of 2, or method 2. You have to somehow distinguish between the two graphs. Alrighty, here's our point of intersection. We've just worked out that that occurs when a number of units of gas is 100. So 100 units of gas. And we can work out the cost as well, because the cost will be there, and we just have to substitute 100 into this either equation, because you're going to get the same cost at that point. So there's our cost. And okay, so we've done that. What does it say? Determine the number of units. We've already done that. But if the question did say, and what would the cost be? You'd substitute 100 into either equation. And just so we have a look at it, when would it be better to use method 1? If we use less than 100 units, so from here to here, less than 100 units, I would want to use this equation here, this method, which is method 1. I don't want to use method 1 for this between 0 and 100 units per quarter. At 100 units, it doesn't matter which method you use because they're both the same cost. And then the cheaper one, after 100 units, would be this one. So I'd use method 2 for anything over 100 units. So that's our understanding that you have to try to work out, and they're the questions you might get in a test. Alright, let's move on. These are pretty typical questions as well. 3 kilograms of jam and 2 kilograms of butter cost $29. 6 kilograms of jam and 3 kilograms of butter cost $54. Find the cost of each one for 1 kilogram. Alrighty, first thing we need to do is define the variables. It's pretty obvious. I'm going to say let J equal. Do not say let J equals jam. You will lose a mark for defining the variables. Let J equals, it says find the cost. J is the cost of 1 kilogram of jam. And let B equals the cost of 1 kilogram of butter. Okay, we've defined the variables. Now it's pretty easy to write the equation. So 3 lots of J plus 2 lots of B is equal to $29. Next one, 6 jam plus 3 butter is equal to $54. Now we've got our simultaneous equations written up, use CAS. It's the easiest way, but just because I like doing it algebraically and I didn't bring my CAS, I'm going to just quickly show you the elimination method this time. You might have forgotten, there's equation 1, there's equation 2. I'm going to make these two the same number, so I'm going to make them both 6j, but I'm going to make this one negative 6j. So I'm going to times this whole equation by negative 2. So if you have no idea what I'm talking about, don't worry, just use CAS. So this one will be negative 6j minus 4b, because I'm multiplying that by negative 2, and that equals negative 58. The reason why I made it negative is so now I can add these two equations together, equation 1 and equation 2. So the j's cancel, and here I'm left with negative b is equal to negative 4, so therefore b is equal to 4. So you would have done that on your CAS straight away, it would have given you both answers. So the cost of 1 kilogram of butter is $4. How do I find the other one? I substitute this into either equation. So I'm going to put it into the first equation just for fun. So I've got 3j plus 2b, 2 4s are 8, is equal to 29. 3j is equal to 21, take away 8 from both sides. Divide by 3, j is 7. So now I can answer my question in words. The cost of 1 kilogram of butter is $4, and the cost of 1 kilogram of jam is $7. Good job, everyone. But remember, just use CAS. Don't be stressed if you don't understand that method. And the last one I thought I'd throw in there, the sum of two numbers is 73 and their difference is 37. Find the numbers. Okay, I'm going to call the numbers x and y. Defining the variables, let the first number be x, let the second number be y. I'm just going to write x and y. Sum means plus, so x plus y is equal to 73. Their difference is 37. We don't know which one's bigger and smaller, it doesn't really matter. X minus y is equal to 37. Use CAS again, but in this case, there's a plus y and minus y. I'm just going to add them together, called the elimination method. So I get 2x is equal to 110. So I get x is equal to 55. So if x is equal to 55, I substitute that into either equation. I'll put in the first one. 55 plus y equals 73. Y is equal to 73 minus 55. What would that be? 5, 15, 18 I get. And you can always check, and then you answer the question. The two numbers are 55 and 18. You can check, you add them together, and I get 68, 73, and the difference is 37, 40, 55. Yep, they work. Good job, everyone. So, now that we've done that, please just do the whole of exercise 21G, and then we've got one more exercise, and then you can do the chapter review. Good job, everyone. See you soon.